Good day to you. Today's video mathematics lesson is on measurement. And many of you did quite well yesterday on the little quiz thing from the district on analyzing the the line graph with the data with the x's. So you had to add some fractions there. And then converting from minutes to hours or that kind of thing. So the reason I want to talk about this one today is this. We have this measuring tool device. Interestingly, this measuring device, the other way, is only in American inches. Okay. This one, though, and I think it's important that you know the difference, has both inches and centimeters on the bottom. So it's kind of nice. So it can allow you to measure things in two different ways. Now, I want to talk about the difference between centimeters and inches because that's important. So the metric system is going to be the centimeters. But before we do that, there's a case in my life recently of installing baseboards in our house. And there's many instances where I needed to add unlike fractions or subtract unlike fractions on the tape measure. And if I were to look at this tape measure again, let's say I got to that point where it's 3½ right there, right? And then I had to add to it 2 1/8 to be exact on my measuring. So clearly the 2 and the 3 are going to get us up into that category, right? But the question is, what are the fractions? So as we look at this, okay, we've done this plenty. Maybe some of you are doing already math, but it can never hurt to review it. Clearly, here are 5 inches because we're adding the 3 inches and 2 inches, but we also want to add our fractions of an inch. But 1/2 and 1/8. What do we say about 1/2 and 1/8? Well, it's 1/2 and 1/8 together, but we need what? What do we need such that we can add fractions together? We need common denominators. Common denominators. How do we make common denominators? That's this guy. We want these guys to be the same, right? To add those together when we're using a measurement device like this. Yesterday's little quiz thing, you didn't really have to worry too much about that because the way that those math problems worked out. But in this case, we need a common denominator. So what can we turn them both into, or what can we just turn one of the other ones into? And I've talked about this in the past of apples and apples. If you have 3 apples plus 2 apples, you have how many apples? 5 apples. Well, in the case of fractions, we have halves and eighths. That's like an apple and an orange, halves and eighths. We need to either turn the apples into the oranges, or we can turn them both into fruit. And when I say that, I mean we can change them both into a number to make them common, to make them the same. In this case, we could turn them both into 16s, we could turn them both into 32, and so on and so forth. But we don't need to, because we can turn a 2 into an 8. So let's take the easy route. That makes a minimal word. And you also get a simplified fraction. So we're going to use, what do I call this guy? The magic 1. Why do I call him the magic 1? Because it's just 1, 4/4. Magic because it can change the look of a fraction without altering the value of that fraction. Okay, so we're multiplying. You can also divide because you're just multiplying by 1. You're not changing the actual value of that half. You're just making it look different so that we can then add it to the eighths. Why the 4? Because 2 times 4 is 8, and I want 8 as my denominator. So notice it becomes 4 halves. 4 halves is the same as, 4 eighths is the same as a half. 4 eighths is the same as a half. So I haven't changed the half value. I've just made it into eighths now. And if we were to look at simply on the tool here, let me get the lighting right for you there. So it's kind of messed up. Okay. And we were look at the half mark there, right between the 1 and 2. You'll notice right before the half is a 3/8. Well, then it goes 4 eighths, 5 eighths, 6 eighths, 7 eighths. Okay. We can also make them in tinier slices by making them 16ths, or even tinier than by 30 seconds, but we don't typically do that, depending on how accurate we have to be on our measuring. So then now we can add these guys. We have 8s. We have both the same denominator, so it's 4/8 plus 1/8 is 5/8. We don't want to forget our whole number. So that would be those two fractions added together using this device. Now, the beauty of the metric system is, okay, doesn't line up. Notice it does not line up exactly with inches. Okay, so they don't line together. But what's nice about the metric system is it allows us to work in the base 10 system. So it's particularly nice when you're adding fractional parts of a centimeter. Now let's talk about that for a second. So I've covered this before, but let's review. Centi, okay, meter. Centimeter. 100. Okay, so in a meter stick, it's about like yardsticks, meter sticks, okay, meter stick, there's 100 centimeters. How many pennies are in a dollar? 100 cents in a dollar. So that can help you century. How many years in a 100 years? It's, well, in a century, it's 100 years. Okay, so centimeter. So in a centimeter is handy because let's say that we had parts of a centimeter and parts of another centimeter. In other words, if we had, say, for example, 3.6 centimeters, okay? So 3.6 centimeters, if we look at a centimeter stick-ish, got it? So we're looking at right in here, okay? 3.6, now you gotta ask yourself, wait, 0.6, what is that as a place value? It's 6/10, right? That's because this part is a millimeter. Okay, so you have a centimeter like this, and within a centimeter, you have 10 millimeters. Okay, milli, 1,000 parts in a meter stick then. So within 1 centimeter, and by the way, I've told you this too, a centimeter is about the width of your finger, your finger. And then if you think about that much, then your nails, your thumbnail perhaps, is about a millimeter thickness, because 10 of those would make a centimeter. So if you touch your fingers, you can think about that as a centimeter. And again, it works in the base 100 system, which is super nice. So let's say now we're going to add to it 2.2. We don't have to worry about renaming the denominators and all this and the fractions, because it's a place value system with just base 10, base 100. So we can just add our tenths and we can add our whole. So that's why the metric system is pretty handy. Okay. Now the metric system is really good and just as good as, say, inches and feet and so forth. It's just that if you look at, there's 2.54 centimeters per inch. And so what happens with that is if you're measuring something quite large, okay, you're going to have big numbers to deal with. So like in that garden, it was 70 inches. Well, if we converted that, 2.54 times 70, you're going to have in the neighborhood of 170-ish centimeters. So they start to get big numbers. And then when you're multiplying for area and all that, it's kind of big. So it's sometimes got to decide on which measurement system is best to use. But again, what's nice about this measurement system is that we're just dealing with the tenth system. Now, if in the case of centimeters and metric system, you notice the place value, again, as adding and subtracting with decimals, if I had a bigger number, it's no big deal. Just line our place value up to add them up. Okay, so let's say it's 21.7 centimeters. So that's going to be 7 millimeters within that 21st to 22nd centimeter. And then almost 5 centimeters, not quite, we have 8/10 of 8 millimeters within that next centimeter. When we add these, as long as our place values lined up, we're golden, because now I'm going to say 8 plus 7 is 15, and I'm just going to regroup that 1 up here. Because 8 plus 7 millimeters would be 1.5 centimeters. And you can check that out. You look on your tool. You got a tool at home somewhere that has millimeters on it? Okay, so if you look at millimeters, and if you were looking at that and you said, well, there's point, you know, it's kind of tricky to see them a little bit on these, but there's 10 little dashes within each centimeter. Those are the millimeters. Notice how it's divided with that half mark, like right there. Oops, hold on. You'll notice the half marks are a little bit bigger down the center line to give you that half mark, 0.5. Okay. So then we just regroup that 1, and then we can add our 1s to get 1, 2, and a 6, and then nothing to regroup, 26.5 centimeters. I say 26.5 centimeters, even though this half, these 0.5 is really millimeters, but it's half of the next centimeter up. It's half of the 26 to 27 centimeters. Okay, we good with that? So that's a little bit about measurement and choosing the correct tool and which tool you'd like. You'll notice that probably using the metric system can be a little bit easier, both in addition, subtraction, multiplication, and division, than the fraction system. There are cases when fractions that you can convert to decimals fast, right? So for example, if I look at, if I write, say, 3 1/2, but instead of a half, what is half as a decimal? It's 0.5. So then you can convert that. But when we're talking about eighths, you can't do that as easily. So you're going to have to work within the fraction system of eighths or 16ths or 32. So in those cases, you'll rename your fraction. Okay? So real world examples of using that system was me installing baseboards. But who knows? For you, it might be building a structure out of a paper towel tube so that you can roll a marble certain distances, and you want to decide on the lengths you add to get the right amount, a distance you need to cover, and so forth. All right. Or if you're doing some programming and you want to get your OZABOT to travel a certain distance, you might use this concept for those things. Just remember, when you're dealing with fractions, it's really nice if you can learn at least half of it. You get it? It's a fraction joke. You know, I really love fractions, at least part of them. You get that? What I did there is I made a little joke using fractions as part of the joke. So, you know, if you got part of my joke, it's good. There's another one. All right, we'll see you later.